if you like. So we're going to hear from her. And cybersecurity is a very important topic today in broader area of computer science and in AI in particular. So there's a lot of things to learn about. So with that, we'll just pass it to you.
Logistics. What time should I finish?
We have basically 15-minute class, so 45 minutes would be great.
Okay, absolutely. Thank you. And thank you for inviting me. And nice to see some familiar faces in the audience. So it's always good. I just get one of the biggest compliment on a semester. So from a former student of mine, not in a security course, but in a database course, mentioned that she could use what I taught her in a database course to actually implement a database in the summer. Okay. So today is just really a very small segment of my research, because I could talk 50 days, not 50 minutes of what I've been doing for the last 24 years. So let me start out a little bit about who I am, besides being a professor in cybersecurity. My way to computing and cybersecurity is...
Well, just to capture your...
Oh, sorry. Well, I want to see the slide, not
yeah.
But anyway, so my way to computing is somewhat unusual. I did not start out as a computer scientist or even somebody who was interested in computers. I was a geologist. And I was working, after getting my bachelor's degree, I was working for the Hungarian oil company looking for petroleum reservoirs. And guess what I had to do? Deal with computers, okay? So the good old days when we would hike outside with a hammer in hand and a backpack were over. So I was spending most of my days and studying. This is a seismic record collected by, seismic exploration to try to map the underground surface of the world. And one of the earliest users of computing technology is really coming from the oil companies, because to deal with the large volume of data. So one thing that working as a geologist taught me, not only that I need to deal with computers and I need to learn how to use them efficiently, but also taught me how important it is when I'm dealing with data to understand the meaning of the data, okay? So I didn't start out as cybersecurity. I started out actually as somebody dealing with data. And I put this slide in because it's very easy to imagine when you're looking at this as a segment, like a crosscut on the underground of the earth. And imagine that the vertical axis is the depth. Now, in reality, it's not the depth. It is a seismic reflection time. It's that they create an explosion on the surface as the seismic wave travels down in the earth crust. It's reflected from the different layers, and sensors collected the data, processed it, and so on. So we as a geologist, we got it. So my very first job as a geologist was to correlate between seismic reflection time and actual depth, because we did have wells that the oil company drilled in the earth, and it provided us with electrical engineering data as well as core samples. And we needed to set it up with the surface underground. Okay, so first time I saw the record, I said, "Oh, this is really." When I saw 5, is it 5 kilometers or 500 meters, or what does it mean? Turned out it was 5-second reflection time. Okay, so luckily for me, the company not only appreciated my interest in computer, but sent me back to school to get another degree in computer science. So that's my long way to go to computing. And when I moved to United States, I got lucky and I entered the graduate program at George Mason University. And that's where I met with Sushil Jajodia, who became my advisor. And he was working a lot in database security issues. So that's my pathway.
In database area, and Sushil is a good friend. Now I'm no longer really coordinator.
But I did meet with Dr. Amit Sheth afterward when I started here, and when I got my second NSF grant dealing with the semantic web data security needs. And you were working on ontologies and semantic modeling. So that's how actually, so right now, and this is not, oh yeah, okay, it's just slow, good. So I started out in a classical unstructured data because that was most of the geological data. My PhD dissertation focused on security need of structured data or relational databases. And since then, I basically dealt with all sorts of different data model for semi-structured XML data model, unlinked data, as well as high performance computing scientific databases. So my primary interest in all of these areas is what do we want to protect? Why do we want to protect, and how can we protect it, and how can we express these protection needs? So really, over the last 24 years since I've been at the University of South Carolina, I had several projects. Most of them are funded by the National Security Agency, National Science Foundation, National Security Agency, local Department of Commerce, and so on, Air Force, IBM. So as a faculty, it's very important that we carry, research. So my interest and primary focus here will be database security, and how I use semantics overlaps the policy aspect. This is that when you specify that what we want to protect in a high level language. When we talk about security policies, we also need to understand how expressive that language is, how detailed, how realistic security policy can I express using that language, okay? And there is a lot of improvement over the years of starting out from the basic model that those of you who use Linux or Unix are probably familiar with, that, owner, others, group, that you can specify. We came to a very expressive, very capable security policy language. So I try to understand, and when I design security technology, how can I express what needs to be protected? I also very interested in what I mean by granularity is that what is the smallest unit that I can provide a protection? You can imagine that my laptop, but maybe it's a file on my laptop, or maybe just one particular email in my email server that I want to protect, or maybe I want to express the protection is the entire computer systems. There is an advantage, disadvantage of which level you choose. So obviously, the smaller the unit that you can protect, the more flexible your policy is. You can custom tailor for every user's needs. But at the same time, you are going to spend a lot of effort managing the security policy. So you need to have something that is realistic, something that is practical, okay? And after that, you have a security policy, then you need to enforce it, okay? So you have a high-level policy. Everybody is familiar with the FERPA regulation in a university because it impacts all of us. At least in high level what it does or what it requires. How can I implement it, say, in my classes? Or how can the department implement for our students, okay? A very important aspect, I mentioned FERPA, but I can just say HIPAA. What is the compliance? Health information. You're running an AI system on some health data. You better prove that that AI system is HIPAA compliant if it's really accessing real patients. Okay, so that's very important. And how costly is, when I mean a cost, not the dollar sign, but computational power. What is the overhead? Again, one of the aspects that oftentimes when people hear about security and like average users, when they hear, oh, you are the security engineer or chief information security officer, they say, oh, you are the one who's making our life harder, right? I don't know if you interacted or actually talked to some security people and thought that they're just creating issues. You have to have dual authentication. We can't just use password anymore. It was so convenient in the past. You could save your password on your browser, just click on the link to connect, and you didn't have to do anything. Now you have to use a second device to go through Duo, and now they're changing Duo. You don't just have to push a button, but you actually have to enter a number that Duo pushed us to. So security people may add some extra work in an organization, but at the same time, their focus is to enable an organization to carry out their work. We're not coming up with security technology just to make everybody's life hard, but really to make the system capable to function properly and not being corrupted or attacked by, successfully attacked. And that's a real tough part for the security person, is because we can't say that if you implement this security, this is how your productivity is going to go up. We don't have a return of investment. What we have is no loss, and it's much harder to justify. So that's one of the aspects that's come back. Generally, when we talk about security requirements, we talk about the security objectives. And I'm sorry, it is a little, I guess I need to do it faster. I already switched my slide. Okay, good. So I just hit before I need to move. So the top 5 are that really becoming the classical security objective. Confidentiality, but everybody consider that secrecy. Okay, what is the data that you want to keep secret? But security is much more than confidentiality. Just as important is integrity. How correct is data relating to AI, fake news? That's part of the security, okay? Incorrect data, outdated data, these are all part of the security consideration. How available the data is, okay? So availability, you probably heard about ransomware, impacts every aspect of our life, okay? And of course, we want to make sure that authentication, the origin of the information or data is correct, and we can prove actions carried out by an attacker. I put privacy as a separate line because privacy is sort of a stepchild in security. If you think about security policies, there is an organizational body, whether it's a federal government required regulations like FERPA and HIPAA. It could be security by the organization. The University of South Carolina has its own security policy and requirement. But privacy is a much more personal. So that's why I put privacy on that. The same technology that we use for confidentiality can be used for privacy. But people have very different privacy requirements, okay? I may not care if somebody accesses my medical data, but I may be more cautious about that. I want to protect my age, okay? So it's really belong to the individuals, and it's very, very hard to come up with privacy policies for a larger population. So that's why I put it slightly different. It's very closely related to confidentiality. Throughout my research, in addition to protecting directly, like creating access control or authorizational requirement, I'm also very interested in accessing data, disclosing some content in a sneaky way. And I know I don't want to create bad names for inferencing, because in AI systems, you are doing a lot of inferencing. But it has been shown over the last several decades that attackers, not always going in a harder way and try to break in the system or find vulnerabilities of the technologies, but they can gather information and put it together in a meaningful way to disclose something that may be confidential. And if you think about open source intelligence, that's one of the examples, when you are gathering only publicly available information and use it to, infer something about what's going to happen. So my PhD dissertation indeed focused on the inference problem in relational databases. So how can, a malicious user use the existing database constraints to infer something that should be confidential, okay? So that's what I call the general purpose databases. It is a well-known problem and studied and still being studied extensively in statistical databases. And I guess AI databases, since you're doing some statistical studies on that, would fit into that domain as well. But the example would be in statistical database like Census Bureau. We want to give out information about the population, not about an individual. However, we know if we give out information in, let's say, a small group of population, small number of members, it can be used to disclose about exactly, information about the particular individuals. I don't know how many of you remember when Amazon started to post about what people in your region ordered. I don't know if it might be beyond, older than you are. It's been a few years ago, but that was an uproar. People got really upset because they said, hey, only if, especially in a rural area, there's only a few people who live here. When you post that something has been purchased in this area, it violates my privacy. We don't want to do that. Facebook had some other issues too, when they, I guess, posted your friends, or I'm not a Facebook user, but so this inference problem exists. To tackle it, it's very difficult, even in a classical database context, when you have a centralized or a database system, even if it's distributed, but within a single control. When you have widely openly available data, that creates a much bigger problem. So my research, what I try to do, and it's really, I would say from the very beginning, since I work in an area, is to look at the data and the metadata in a larger context. What additional knowledge the attacker can bring in that would make the attackers or the unauthorized individuals access to the data, and what can they do with the data? Can they, corrupt it? Can they destroy it? What is the protection I need to come up? So this is sort of an overview of several of the aspects that I've studied over the years. So I focused a lot about how to, in a semantic web context, I have to specify what is the data, what security needs we need to implement. How can somebody use publicly available additional data to combine them together to disclose things? So for example, an example of this undesired inference could be is, say, when it actually happened to the US government, they shared rifle simulation software with friendly nations. And it turned out that using this software, along with publicly available web data, allowed the attackers, that were students, who were able to explicitly say what type of weapon the government used to simulate with that software. Basically giving information about what kind of weapon system the military had, okay? So I'm very interested in both defining that what is the protection object, and then how can we protect it, express the security policy, and then implement this policy in a way that even this indirect access, disclosure of the data is not possible. And I studied it in an organizational setting. So what can a company do? What's happened with social network when people share information? How can it be used against them when they combine this information together? So really the question is, security is from the perspective of a larger company that have a security policy, but privacy issues are just as relevant. Some other example of the inference attacks, I don't know if how many of you have any wearable device, smartwatch, Apple Watch, or this is a Garmin that I used to use for when I go out jogging to medium distance. How many of you heard about the Fitbit? Few years ago, when what was it, Fitbit or Fitbit? The Fitbit that they provided statistical information about the usage of the watch, and it actually disclosed previously unpublished confidential military base locations. And the whole idea was, military people would get up in the morning, go out exercising, and this flare up of the level of activity indicated that it's not 100% inferencing, but this is the type of issue that I am interested in. So I already mentioned data. I already mentioned metadata, basically data about data. I mentioned security and inferencing. So a recurring theme of most of my research is how can I use technologies like, semantic modeling, ontologies, knowledge graph to support my security, both for expressing the security needs and help me to detect if there is any undesired inferencing, as well as to represent the actual semantics of the data. This is an example of an ontology that we extended from the IoT ontology developed by the World Wide Web Consortium, and we added, security capabilities for expressing the security policy as well. And this research that this one represent was focusing on streaming data, very, very upcoming, when you think about sensor network, social media, social network, wearable devices. So streaming data really taking over the world in a very rapid pace. We modeled the security for the streaming data. Okay, so using ontologies is a returning point. We use these ontologies and reasoning capabilities to express the security policy. This is the upper level. So based on the reasoning engine, we define security objects. So we assign security requirement for that object. These are high-level representation. Those are not actual, say, data item. It's not, doesn't say that, okay, this is the medical record of Csilla Farkas. It's a much higher level pattern. I would use the word pattern. And then we use this pattern to actually enforce it on a particular database instance. Again, this one was part for that streaming data. So you can imagine this bottom bar is the actual streaming data that changes rapidly as new data is generated and transferred. And we used an implementation to actually add security punctuation. Those are the green, red, and purple signs, when green stands for public data, S for secret, and purple top secret. So which means that at the receiving end, it is being interpreted as that anything that follows green is public, and when the security level changes, you get a marker, a punctuation for, say, secret and top secret. Now, it sounds very, straightforward. The problem is when you deal with this data, that how can what happens if I need to distribute the data for different users? So a top secret user should be able to get everything, while a public user only get the public data. However, by missing data, so whatever is not permitted, that also gives out an inference, because it tells that, hey, you're not permitted. There is something that you are not permitted to get. And those of you who were in my 522 class, that's actually an example of covered channel, which can be used as a signaling channel. So I did several years, probably more than a decade, is just trying to understand the different data format and say, what can be that pattern that I'm modeling? So this is one of my early works back in probably early 2000s, okay, 2003, 4. So it's, since then the technology changed a lot, but back in 2000, XML was just an upcoming data model, used primarily for data exchange. So this is an example of an XML file. And the question is, if I have multi-level different security levels within the file, how can I release it to the end users? So in this case, we try to come up with a model that we can release the data to the different level of users without disclosing that something is in between not permitted, but without messing up the semantics as well. So I don't have all the slides. We published in several conferences and journals, but the basic idea is if you have to remove something, a node internally from that XML tree, it breaks the structure. If you break the structure, you lose the association between the data items. So I may no longer know, for example, whose grade am I releasing? Is it yours or yours? Because I'm no longer linking it to an actual individual. Back in those days, that the industry, who was very much started to implement and use XML very widely, they solved the problem in a very easy way. They said, okay, security can only increase as you go down in a tree. So you can't have anything that the root is public, then you have a secret file, then you have another public along the one path. So basically, industry is very good to come up with practical work, not necessarily the most flexible. So it did work for industry as researchers that, okay, how can we do it better? So it came out. Similar with the streaming data. So it's very easy to look at a single stream. But what happened, for example, if I would have multiple cameras here, and I want to integrate the difference, maybe to have a 3D view of the room, but say there is something confidential on the other side, Dr. Chef is running some top secret experience on the other room, so any camera that would go over there should be considered confidential. Can I use some other camera streams to actually recreate what's missing from there? Okay, so we came up with security requirements that maybe a single data stream is not confidential, but when you combine multiple streams, when you bundle them together, it will become confidential. Okay, and of course, when you think with streaming data, because it's time sensitive, when was the data? Imagine that not only camera, but imagine there is a thermometer that broadcasting information about, say, a chemical processing plant. And the temperature is climbing up, but the person who is working in a control system is not paying attention, and there will be an explosion. We know that this happened in the past. So can that person change the order and move a later data stream to an earlier part, or even completely remove it and say, I didn't know about that the temperature was rising. Maybe he was watching video. Can they do that? And sadly, these days, most systems that when they provide security, they only provide security to endpoints. So either everything is protected or nothing is protected. So changing the order is indeed possible based on the current technology. So yeah, I'd like to talk about security, sorry. By the way, if you have any questions, please feel free to interrupt. So one of the areas that I studied security and focusing on data security and privacy is smart IoT environment. That was an NSA funded project. So you basically created a smart sensor network, and we defined security policy, and we modeled the context of that environment and use this context to set the security level and dynamically changing the security requirements and processes. Yep. So, and I mentioned dynamic. It is a very important aspect because our environment changes all the time. So our security policy should change accordingly. So, I like this slide by Heraclitus back in 500 before Christ. He already mentioned that the environment changes all the time. So why is our security policy static? Why don't we have policies that they dynamically adapt? So my latest research, what I'm doing is using the context as the dynamic changing force between the security policy and changing the security requirements according to the changes. So one of the example, and it's actually one of the classical example, is how to deal with emergency scenarios. Okay, we have HIPAA regulations. Under normal scenarios, yes, I don't want people just to access my medical information. If I have a medical emergency, I want that paramedic to be able to look at all my files so I get the best possible treatment at that time. Okay, so how can we achieve that? How can we do it in a way that does not require human interaction? Maybe we can have a human oversight, but we don't have to wait until somebody actually changes it. We humans are actually pretty good at dynamically adjusting to the environment and make changes. But if the computers especially the security technology needs to make changes, we need to have some feedback. So this project was focusing on wearable devices, bringing together information from these devices to infer if there is an emergency scenario, and then change the smart environment, the smart home that maybe calling 911 or request a communication with their healthcare provider. So instead of waiting until say a patient initiated those or a human, that was automatically done. Another aspect is changing environment. It's also changing the environment is very important when I talk about privacy. And this research was really motivated by, we had a former faculty member, Dr. Jenny Beers. I don't know if anybody met her. She was working a lot with elderly people, older adults, and technology supporting the aging in place. So this is actually a double. It's a picture of a double that people used to provide, monitoring of patients, and was able to, healthcare provider could talk to the patient through the double and so on. Now, one of the issues that most of the patients complain about is that I don't have control over who is seeing that data, and I don't like the double following me to my bedroom or my bathroom. Okay, now this research combined together both location-based security. So say in a home environment, you could set up, where the device can go, as well as adaptive security requirements when there is an emergency scenario. So, yes, the device is not permitted to go to the bathroom. However, when the elderly person is in a bathroom for an hour, or just giving up a number, that could be used as the reason that indeed there is an emergency scenario, that bypass the security and look up what's going on. Okay, so this was one of the work. Finally, in the same smart home environment, we also looked at, what else can we do besides talking about security policy and adjustment? So that was a project with my group of undergraduate students, and they came up with several potential use cases, scenarios, when the same technology can be used in an unexpected case. So, and this is a simple use case of what happens if there is a fire in the house, and what is the mitigating effect if there is a fire, what is the damage, and so on. So one of the questions was, that's fine. What about if the person living there is hearing impaired? Even if you have the fire alarm, they won't hear it. They maybe, won't smell the fire yet. They won't hear the fire, so they will not be able to evacuate to safety. So one of the students said, we have smart light bulbs. Why can't we signal SOS, and create an alert? And we can put a light outside of the house and also can signal, so maybe somebody passerby will see that, hey, something is, I don't know how many people knows the Morse code for SOS, but you probably see that light is flickering in some pattern, so it might make somebody go in and help. So that's another aspect, is how can we use the technologies, this, not necessarily security from the perspective of the system and the data, but in one way supporting the human. Okay. So these were so far the classical security capabilities. We also dealt with issues, what can I do when somebody is not available? So basically two concepts, how can we incorporate in this context-based security technology is delegation and obligation. Delegation means if the person who is able to carry out or requires to carry out the task is not available, who else can do that? And again, if somebody may get an access, but if they get the access, they may be obliged to carry out some additional work that's not necessarily in systems. Again, the underlying aspect is that we created delegation and obligation ontologies to express this requirement and use the reasoning engine to actually derive when we needed to carry out those technologies. In addition to IoT, my most recent projects address security requirements in the context of critical infrastructure. And this is unique, not only because our national security depends on the safety and security of the systems, and of course, critical infrastructure component attract attackers that not the classical cybersecurity attackers. There are nation states, terrorist groups, and so on with lots of capabilities that carry out the attack. One of the uniqueness of these systems that they generally were not designed with cybersecurity in mind. Oftentimes when you think about critical infrastructure, almost everything were based on physical security. And even these days, for example, the electric grid, although there is more attention to cybersecurity in electric grid, but generally physical security is the major aspect. Okay, they worry about somebody going next to the next switch and using a machine gun and create a disruption, or a hurricane taking out some of the distribution. Okay, but because those systems rely more and more on remote access, so our work actually in this context, critical infrastructure, focusing on strengthening the remote access, using the context of the critical infrastructure that the user is accessing, how critical that component is, and the context of the remote users to establish the level of security needed and basically randomly select authentication factors. So if you think about to be used for authentication, if you think about duo and it's using duo push, what we are doing is we're using multiple different factors for authenticating the remote users. Another
one question.
Yes.
In our first sessions, we talked with Vignesh. He has given a talk about
Yeah,
it,
physical
about the dynamic systems. I think those two things are kind of related.
I'm not sure what he talked about with the
The
dynamic
dynamic
system.
systems control in terms of the critical infrastructures like
Okay.
wireless sensor network, water distribution
Okay.
system, and network transportation.
Yeah, that's so we are not focusing on the dynamics so much, but the focus on the dynamics of the critical infrastructure is what is the process. So we're actually going down a little bit more in details on, okay, what is that industrial control systems, what process is running on, is the user going to access that, and that will determine the level of security that we need to guarantee during authentication. And this one also reminded me that oftentimes when people talk about critical infrastructure component, they sort of downplay the security because what they say that, oh, it requires a special knowledge. Not everybody knows how an industrial control system works, okay? And not everybody knows how it's being implemented. Unfortunately, with this age, when so much information is available, I mean, that it's good that we have all this information, but unfortunately, when somebody tries to base the security on hiding the inner working of the systems, they open up for external attack. Okay? So another unique area that I'm working on, the cybersecurity of HPC, high performance computing systems, in particular for scientific workflows. It's probably because of my geology background and I was very interested in scientific databases. But one of the things, and again, it's not on a confidentiality, oftentimes those data is actually publicly available, shared, but reproducibility and validation of the results. And the question is, scientists have their own requirements and setting up, so they know how to set up in a real lab and keep good track of what's going on. When it goes to high performance computing environment, then they lose control. Okay, which core your data is being executed, how is it split up and divided? So providing reproducibility is a very difficult concept in the larger context and high performance computing. I am a member of the working group at the National Institute for Standards and Technologies that actually we just published at the beginning of this year, and NIST 800 publication on HPC cybersecurity posture. It's not a regulation, not a standard yet, but it's a posture. I'm very interested. In particular, what I bring in is in databases, which is, I have several decades of experience. We have the capability of detailed logging and know what each user is doing. HPCs can't afford it. It's a much larger units of data that we are dealing with and logging. So how can we provide logging without actually crashing the performance? Because we also want to make sure that we minimize the overhead for any type of logging and processing, okay? This one involves from blockchain technology to, coming up with security policy, automatically collecting data in HPCs to guarantee, again, the reproducibility and validation, not so much for the confidentiality. And finally, I don't know if any of you remember, when was it, last year, the Colonial Pipeline ransomware attack? Has anybody had any negative consequences of the attack? I know I was stuck up in Durham for 4 days because I couldn't get gasoline to drive back home to Columbia. So I was stuck there. And that sort of started me thinking about what is the impact of cyber attacks on the society, okay? Not about individual, but different segments of society. And this research is sort of a continuation of the work that I did several years ago with the geography department. I don't know if you know Susan Cutter.
In fact, I saw this SVI, so
okay.
That's what reminded me. I did
Yeah.
proposal with her.
So the whole idea is we already know that natural disasters impact different segments of the population. Think about what was the city down in Gulf of Mexico? Katrina. The effect of Katrina, okay? So, the poorest segment of the society was impacted disproportionately because they could not evacuate, okay? So the question is, and being stuck in Durham, and luckily I had a friend's house where I could stay, so I didn't even have to pay for a hotel. But I just thought, what would have I done if I need to come back because I have a work, like something that I cannot do remotely, and I have no money, and I cannot buy gas? What would have, society? So I am sort of reigniting this work to say that looking at cybersecurity, that's actually could be something interesting in AI. And I don't have a slide here, but I also very interested in the ethical use of AI and what can we do at the technology side and what the legislations and the requirements have to be doing. It's, not enough time to do that, but I was very interested in that, we can't control how somebody's using AI. Can we regulate it? And the European Union is going really speed ahead on that. I think that my time is running around. So the very last slides, I don't know how much of interest of this group, but I'm also very interested, as Dr. Shet mentioned, I'm doing I'm wearing multiple hats. So I am the point of contact at the university for the National Security Agency to be designated as a National Center of Academic Excellence in Cyber Defense, as education, as well as for research. So what this designation will give us is unique scholarship for students. Okay, now the scholarships are coming from NSA and DoD. So it's unfortunately not available for everybody. But one of the type of scholarships that I am leading the effort to support students to apply for, it's not coming to the university. It's coming to university, but it's coming to individual students. So it's not that we get a chunk of money and distribute it as we like. If students need to apply and they get it, is the Department of Defense. It used to be a cyber scholarship program. They renamed it starting this year. So the new name is Cyber Service Academy. It is a scholarship that is available for US citizens only. Okay, actually, I have a slide on that, but let me talk a little bit about the scholarship. So what the scholarship provides is full ride, all tuition, all fees, all healthcare expenses, not expensive, but the fees are covered by the scholarship. It provides money for laptops and textbooks, and it provides a stipend. So in 1 year, undergraduates get 29,000, graduate students, whether you master's or PhD, 34,000, okay? And also it provides internship opportunities for the students for the summertime. So there is the requirements to apply is you have to be a student in a NSA designated university. So we are an NSA designated university. So you have to be a full-time student. You have to be a US citizen. So maybe here I'm, you know, not necessarily the best group, but if you are a US citizen at the time when you apply, which will be February 1st next year, the application opens up in October. Reach out to me. I'll be very happy to talk with you about the possibility. You have to have obviously a reasonable GPA, and you have to be eligible to get a security clearance, okay? So you don't have to have a clearance at this point, but you have to be eligible. So meaning that, you know, whatever is the requirement, generally it's drug use or financial problems that make somebody not eligible for security clearance, okay? If you are doing that, or substance abuse, actually, I wouldn't say just drugs, so alcohol as well. If somebody is an alcoholic, I don't think that anybody fits in that category in this group. But so if you're interested in that, it's really, I think it's a very generous scholarship, lots of opportunities. Now, the drawback is obviously no free lunch. So for as many years as you receive the scholarship for one of the DoD agencies. It's very easy to move from one agency to the other. So it's everybody that we have previous students who were in the scholarship. Right now we have 5 students, 2 PhD and 3 undergraduate students in the scholarship. So if you're interested in, if you are a US citizen and you have a job waiting for you, so you don't have to go out and look for that, and working for say 2 years or even 1 year for a government agency, DoD, in the area of cybersecurity or cyber, actually, I take it, but AI is one of the groups. Dr. Sheff and some of the AI faculty members helped us to get the redesignation. So it's very good. You get a job, and after that, the sky is the limit. I mean, that a lot of civilian companies who are providing contract work for the government would love to hire previous employees because you would know how the system works. Anyway, that was my short but spectacular, I guess, presentation. I don't know if we have time for questions.
Yeah. Any questions, please?
Yes,
I mean, I immediately thought of Stuxnet when you were talking.
Yes.
The security for the infrastructure, and obviously there it was usage of the individual people monitoring the you know, and so it was like something they were able to get access to because of the zero.
yeah, 0 day attack.
Right.
Yeah,
So are there other examples that of how we're fixing that kind of thing, like for the power grid and stuff?
yeah, so there is a lot of regulations, you know, that I implemented, and Stuxnet is a little bit of a sore topic for me, and I'm telling you why. Okay, because it hit programmable logic controllers, or PLCs, part of the industrial control systems. Okay, so it's sore point because several years before Stuxnet, I had a PhD student who did his PhD dissertation on PLC, and we did have a very, very hard time publishing his work because academia said that, oh, it's all engineering. It's all practice related because he knew PLC, he'd had several years of experience with it. And industry said, oh, it's not going to happen. We have physical security. And even back in those, if you read some of the PLC user manuals, and it's in his dissertation, we put it in a quotation mark. It said, if this function doesn't work, turn off the security function. So, functionality is over security. So basically, so what happens after Stuxnet? So the government and the industry immediately started to focus on PLC. So a year within that frame, they had hacking competitions who can break into the different manufacturers, PLCs. They strengthen the access to the resources. So for example, some of the facilities, they do have the requirements that any software update has to be hand carried into the system by the trusted employees and multiple people and run in a sandbox first. Stuxnet was carried in actually thumb drive. So they created regulations, backup securities. So for a few years, I participated in the Carolina Nuclear Consortium when they talked about it. It was still very much reluctant to absorb academia research areas. And I understand that they have different requirements. I know that the nuclear industry have a lot of very strict regulation for software updates, compliance checking. So it's really a lot of process strengthening. Interestingly, one more aspect, within less than a year of Stuxnet, one of the Northeastern universities, I don't remember the name, immediately came up with an automated payload generation for PLCs, meaning that, if you don't know how PLCs work, you still can run this tool and you want to say what you want to have the effect, increase the speed of the different components and so on. And they could, they came up with an academic publication that, this whole concept of nobody knows how the system works and we are safe because of that was completely, removed from that perspective. But it's still money. So one more take-home message from my participation in that Carolina Nuclear Consortium was that the question came up that we know that there is a vulnerability component. We know how to fix it. Who is going to pay for the fix? The manufacturer says, well, the vendor says, not us. So somebody needs to cover it, and governments usually run, local facilities, right? Yeah, very done, very, very, low budget. But yes, there is a focus on that. And there is a lot of government, DOD, DHS coming up with new initiative grants. Actually, we do have grants that solicitations for applying by the academia. Any other questions? Well, thank you again.
Thank you very
Appreciate
much.
it.
Yes. Yeah. So, guys, those who came 10 minutes or more later than the class start, can you please stay here and we'll have a chat?
Thank you.